Hi, welcome to this video where we're going to look at security in the IGCSE Computer Science course. This is the Cambridge International version of the IGCSE. It's going to be a two-part video, so in this one we're going to look at some of the risks to data. So what might lead to data being deleted or lost. So first of all, malware. As you can see from the little cheesy animation, malicious software is going to be merged together into the word malware. So this is basically any software that's designed with negative intentions. So it might be to damage a computer, it might be to access your data, to corrupt your data, anything negative basically. So we'll look at all the different categories of that. First is probably the most common, the virus. So just like a real life virus in a medical sense, this is software that can self-replicate, so can spread from one device to another, and usually its aim is to delete data, or maybe to corrupt data, or even to just like destroy your computer by deleting everything, all the programs and everything on it. So the distinction between this and other types of malware is that it has to attach itself to a real program, so it can't kind of run on its own. So it tends to be when you maybe download some software on the internet, perhaps off a not trustworthy website, and within that software or attached to it is a virus. And it can only work when you open that program or run that app or whatever it might be. Similar but slightly different is a Trojan Horse. So this is again a download that maybe seems to be something real, like a video or a song or a program or something, but hidden within the code is something malicious. So you don't realize that you've downloaded something. Generally they don't try to spread, so it's not quite the same as a virus, although these rules aren't hard and fast. A lot of the categories kind of merge, so you have to generalize a little bit. So like a virus, they might try and delete things, they might try and allow a backdoor into your computer so that somebody else can control aspects of it. Then we've got worms. So unlike viruses, they can just work on their own. They spread quite freely. They might try and fill up a single computer, so replicate themselves over and over until the hard drive is full. Or more likely, they might try and spread across a network or out across the internet to replicate themselves. Then we've got spyware. So this is perhaps the most familiar one, or most well-known one, is a keylogger. So if someone manages to install this on your computer, it means that everything you type on the keyboard gets recorded. So if you think that could include passwords, it could include bank details, usernames, email addresses, and generally it will send that data back to the person who created the program, and from that they'll maybe need other software to track through and work out what are the passwords and usernames and so on by looking for patterns. So what are some of the other risks that computer systems might face? Well, again, a famous one is hacking, or a well-known one. So a programmer of some sort tries to gain access to a computer system, and it's often about finding weaknesses, so finding ways in that the company or the software isn't aware of. So there can be a number of different reasons for hacking. Sometimes it's people do it for fun, just to prove their ability. Sometimes they're trying to damage a company's reputation by maybe taking down their website or leaking information that they've found. You do also hear about kind of white hat hackers, which is those who do it in a sort of legal way. So companies employ people to try to hack their systems, and what they're saying is, we'll pay you if you can find vulnerabilities, find things that others might hack to cause problems. But generally most people would see hacking as a negative thing, a malicious intention. Then we've got cracking. It's a bit of a tricky definition for some of these words. So again, hacking is the same. You might find different definitions in different places, so I'm sticking to how the Cambridge exam board defined these words as best I can. Cracking, as far as Cambridge are concerned, is modifying a program's code illegally. So for example, when you download an operating system like Windows, you quite often get the software for free, but then you have to pay to register it for it to work properly. So cracking might be for example, trying to remove that need to pay a fee so that you can get illegal copies of software that don't need to be paid for. Or in the past, these used to be known as modding in games, so maybe modifying a game so it was free, modifying a game so that, I don't know, the player had unlimited lives or something like that. It ties in with the ethics and legal part of the course in the sense that it's breaking copyright laws. You know, the person who creates the software has the right to distribute it as they see fit and make money from it. So if somebody chooses to crack that software and make it available freely, they're breaking copyright law. Okay, then we've got phishing. So phishing with a PH is a bit like normal phishing with an F. It's about hooking you in. So just like a fisherman or fisherwoman has a hook and a bait to try and tempt the fish, in a phishing scam, it's often an email that tries to trick you into doing something. And generally that will be to click on a link which will take you to a fake website. So here is a genuine fake phishing email that I received from the Revenue and Customs. So these are the people who you pay tax to in the UK, and occasionally, if you're lucky, you get a letter generally through the post saying that they've overcharged you and you're getting given some money back, like a refund. So this, for a split second, this convinced me, but then there's several clues we can see on a message like this which give away the fact that it's not genuine. So firstly, it says hi and then there isn't a name after that. So a real company like a bank would always know the customer's name who they're writing to and would quote it in the email. Secondly, we've got several spelling or typing or grammar mistakes. So you might just skim read it and not notice these, but it says weave like rather than weed like to announce that HMRC has recalculate your fiscal activity. They've spelled they with an A. And then another one down at the bottom, the expiration date. So often with phishing scams, they try to pressure you into thinking it's something urgent that you need to do today, or act now to protect your account and that kind of thing. And then what they want to happen is that I come along and quickly click on this link. It would take me to a website that looks like the real HMRC website, but is in fact fake. And if I'd not realised that, I might then fill in my bank details, my national insurance number, maybe a password, and then basically I'm supplying those to a fraudulent website, to a criminal ultimately, who then could use them to go onto the real website to access my money or further details. Okay, Pharming I think is perhaps a bit tougher. It's one of the harder ones on this section to understand, so I'll do my best to explain it with some information and animations here. So a bit like phishing, it's people trying to get you to visit a fake website. It's much harder to avoid though, so you've just seen how phishing can be easy to spot some of the things in emails that might be clues as to it being fake, but it's a bit harder with Pharming. So as an example, let's say there's me on my computer, I've typed in mybank.com on my browser, and what's going to happen, sorry, just animation repeated there. So it makes a connection with the MyBank web server, which sends back the data. Okay, but in Pharming, what happens is a hacker or a virus or something that's on my computer leads to, although I'm typing in the right web address, leads to it getting directed to the wrong website. So again, slightly cheesy example, but instead of going to mybank.com, it's gone to fakebank.com, which may look exactly the same. And again, I fill in my details, thinking that I'm signing into my online banking, and then suddenly, I maybe recognise that it's not the real thing, but it's too late. They've got my card number, they've got my password, which they can then use on the real website. So that's one type of Pharming. So there's the website being sent back to my laptop without me realising. The second type needs a little bit more explanation. I've simplified so far how the internet works, but maybe if you've studied already the internet principles topic of the course, you'll know about DNS servers. If not, a brief explanation. When we go on the internet and type in a URL, such as mybank.com, what should happen is that request gets sent through to something called a DNS server. It's basically a bit like a phone book. So it looks up the URL that somebody has requested, and it has an IP address for that URL. So, computers don't really work off these URLs. These are just easy ways of humans to remember website addresses, but behind the scenes it's all about these IP addresses. It's got a nice overlap with the binary and hex part of the course, so these are each of these 4 numbers is limited up to 255, that's the highest it can go, which 256 might be a familiar number from your binary headings or from hexadecimal headings. And this is IP version 4, which is the older version of IP addressing. IPv6 is more up to date, and that uses hexadecimal. So, a good opportunity for the exam board to have a kind of crossover question between those topics. Anyway, back to this example. So we typed in mybank.com in our browser. It's gone to the DNS server. It's looked up the URL, and it's found that that's the IP address, and then the request gets sent off to my bank's web server, which has that IP address. So that's the normal way of the internet operating. With Pharming, what happens is somebody, very clever, a hacker gets to access the DNS server and change the IP address that is listed there. So you can see again, mybank.com now has this dodgy IP address ending. It's been altered to take us to the wrong place. So we'll just see that in action. So the user on their computer types in the normal URL. It goes off to the DNS server to find out what the IP address is, but it takes them to the wrong web server, and that is the details that will get sent back, the website that will get sent to our browser. So the user's done nothing wrong, it's just the hacker has altered the DNS server. So quite sneaky, very hard to detect. We have to hope that those people in charge of the DNS server have very tight security on this kind of thing. Okay, then we've got a DOS attack. These quite often feature in the news. So what you can see on the animation there, one computer is sending lots and lots of requests to this web server at the same time, to the point where the web server just can't cope anymore. Every web server has a limit in terms of how many requests it can cope with at a time. And then here's a genuine user trying to access the bank's website, but they can't. The website is down. It's just got too many requests, so it can't process any more requests. Why would somebody do this? Well, maybe they've got a grudge with the company. Maybe they're just trying to prove their hacking skills. Maybe they want to take down that company's website to prove a point. Who knows? But this is what can be done. And then a slight variant on that is a DDoS attack. So this is a distributed denial of service attack. So here we've got multiple devices. We've got laptops. We've got some kind of voice speaker thing like an Amazon Echo or something like that, or a Google Home. We've got a tablet, we've got computers. They're all sending these requests. So it's distributed across lots of devices, but it's basically the same concept, to take down a website with too many requests. And where this laptop has tried to genuinely connect, it can't get through because all these other all these other devices are sending requests constantly. Okay, a few more risks to data being lost in different ways. So firstly, accidental loss. We could have things like hardware getting damaged. So maybe a hard disk drive in a portable device, if it's dropped, could be damaged. Again, links to another part of the course, the hardware and software, if you've studied that. We could get software errors, so programs crash, or an app on your phone might crash, and something that you're midway through doing gets lost. And another one is power surges or power cuts. So data that you haven't saved yet or backed up, if you have a power cut, that's it, gone. Okay, so they're all sort of fairly common sense things that could cause us to lose data. Then we've got natural disasters. Again, there's a whole range of these, fire, flood, all sorts of things I'm sure you can think of which could lead to damage to buildings and any data stored on computers inside those buildings. And then thirdly, any kind of malicious actions. So we've got the malware that we've covered previously in this video. Another possible point on that is staff within a company. So for example, if staff are made redundant from their place of work, or if they have some grudge with their employer, there may be a risk of staff wanting to do something malicious to the data that the company stores, whether that's delete it or modify it or share it online or something like that. Okay, so that's it for this video. In part 2 we'll look at some more aspects from the IGCSE security. Hope you found that helpful. If you would like to share this or like, that would be fantastic, or subscribe to my channel.